All right, so 621, how can I solve the system? Again, a system of equations just means that there's two lines on the same coordinate plane, and it will either have one solution, no solutions, or infinite solutions because they coincide. That's really what we're looking at. And today we're looking at equal values method. We've actually already been using equal values method. It's where we say, hey, look, this equals y and this equals y, so they must equal each other. We'll also learn substitution and elimination. I would argue equal values method is substitution, but whatever. Long story short, what we're learning today is stuff we've already dealt with, so hopefully it won't be that bad. We're just giving it a name, really. So a set of two or more equations in the same variables is called system of equations. When you write the two expressions that are equal to the same variable equation, reading is hard, I guess, for me. When you set the two expressions that are equal to the same variable equal to each other, like you did in the previous lesson, you are using equal values method for solving a system of equations. Use the equal values method to solve the following problem. It is time to cool off on a hot summer day. Team Sunshine is filling an inflatable kiddie pool from a garden hose. The pool has 30 gallons in it, and Team Sunshine is adding 8 gallons per minute with a garden hose. Next door, Team Breeze's pool is already filled with 180 gallons of water. They're emptying the pool at 5 gallons per minute. Write two equations to represent the situation. Use the equations to find how long it takes until both pools have the same amount of water. And again, if you've kind of been paying attention, you understand why I went ahead and underlined those, because it's really important to know what the question is asking. And in this case, the question is actually asking us not pool A and not pool B, but it is saying we'll let x equal time, right? How long? Time in minutes. And y will equal the same amount of water. So we'll say water, I believe, in gallons, right? So those are going to be our variables. Now, we're going to have an equation for pool A and pool B, but whatever. So the pool has 30 gallons in it. So water equals 30 gallons. And they're adding 8 gallons per minute. So that's one of the equations. The other one, Team Breeze, has the water in it is 180 gallons, and they're emptying it 5 gallons per minute. So here's our equations, and this is equal values. Hey, look, this equals y and this equals y, so they have equal values. They're equal to each other. 30 plus 8x is equal to 180 minus 5x. We'll go ahead and solve this. I guess I'll add 5x here. I'll add 5x here. I'll subtract 30 here. I'll subtract 30 here. I get 15x is equal to 150, so x equals 10 minutes. And now I'll plug them into the equation. If I plug 10 in, I get 80 plus 30 is 110 gallons, right? Because we said it's y. But I'm going to just check to make sure I get the same thing here. So here, I have the wrong answer. I'll be damned. So 180, oh, this is 13x. There we go. I was wondering why it worked out evenly. In my mind, this question didn't work out evenly, so I was a little bit confused. So what we end up with down here, which is unfortunate that that erased, but we end up with 13x is equal to 150. So if I divide by 13, I apologize for that, so hopefully you guys all caught my error there. So x doesn't equal 10. X is going to equal 150 divided by 13 will equal 11.5, about 11.5 minutes. And now, if I plug those, and I'll use a calculator to plug those into both equations. So 11.53, so 11.53 times 8 plus 30, I'm getting about 122.2 gallons. Again, this isn't exact. And then I should get the same thing here. So if I go 11.53 times -5, again, this is the negative, that's the minus. We got to use the negative key. And then we'll add that to 180. I should get very close, but probably not exact, to 122.2. So there you go. So we're looking at something like that, 11 and a half minutes and 122.2 gallons. I apologize for that. By the way, you know what's good about that was missing that, and I plugged it in here and I got an answer, but then I checked it in here and realized my mistake. So had I not bothered to check it, I never would have known that I made an error. So make sure you're checking your work on this stuff. I did it on purpose. That's what happened. Obviously, that's not the case. All right. So moving along here. Tortoise and the hare. Go ahead and clear myself some space. And let's answer some of these questions. The tortoise and the hare are having a race. In this tale, the tortoise moves 50 feet per hour, while the hare moves 250 feet per hour. The tortoise takes 8 hours longer to finish than the hare. Hey, look, we have a distance equals rate times time problem. So t is going to represent the unknown time and hours it took the hare to complete the race. So we have two equations, distance equals rate times time. First, we have the tortoise. And then we have the hare. So bear with me on this because this gets a little bit tricky. I'll just fill in that they're both going to get their distance equals rate times time problem, and hopefully we'll be okay with this. So it says in this tale, the tortoise moves 50 feet per hour. So I'm going to go to the tortoise and I'm going to say, all right, I know that this is 50. And that the hare moves 250. So I'm going to go over here and I'm going to say, all right, I know that this is 250 for the rate, right? Now, it takes the tortoise 8 hours longer than it takes the hare. So let's say that the hare takes t hours. It doesn't matter. If it took 2, it would take 10. If it took 5, it would take 13. The bottom line is whatever t is, I'm going to go over here and I'm going to add 8 to it. And I need to do it in parentheses because I'm going to distribute. Long story short, they both equal d. So I can say, hey, equal values 50 times t plus 8. Again, 50 feet per hour times however many hours the hare went plus 8 extra hours equals 250 t. I will get, I'll just divide by 50, make this easier on myself. So I'm going to get t plus 8 equals 50 t. And I will get 8 equals 49 t. Something feels so wrong about this right now. What was the distance of the rate? So 50 t plus 8 equals 250 t divided by 50. Oh, that's 5. That makes way more sense. 250 divided by 50 is 5. It's not 50. And it's like, man, this is not going my way here. So I apologize. Making a lot of errors in this one, but at least I seem to be catching them at this point, I hope. So at this point, I can subtract t, and I will get 8 equals 4t. So divide by 4, 2 equals time. So time is 2. If I plug 2 in here, 2 plus 8 is 10. 10 times 50 is 500. So the distance is 500 feet. And again, same thing over here. I want to plug 2 in and I want to make sure I get 500, and I do. So the distance of the race is 500 feet. The hare took 2 hours, but the tortoise took 10. Again, careful on your math, check your answers. I definitely think it's a good idea. Uh-oh, didn't want to push that button. Alrighty. So let's see here. I think I might be done with this one, but no, we have the candy mixture problem now. Alright, so Renard thought that writing 2 equations for problem 644 was easy. He wants to use 2 equations. Am I on the wrong one? No, okay. He wants to use 2 equations with 2 variables to solve this problem. And again, I'm pretty big about just like, let's have our strategy. Let's define our variables, and let's write our equations, let's solve our equations. So here's what we want. I don't even need to read the question, well, the whole setup. I just need to read the total weight of all the bags of candy is 400. How many bags of candy did she buy? So I know B will equal bags of candy. I thought I was being cool here. I guess I do need to read, not bags of Katie, bags of candy. I guess I do need to read because I'm going to need a different variable here. So And I bought several bags of caramel candy and several bags of taffy. The number of bags of taffy was under the caramel. Weighs 8 ounces, 16 ounces. The total weight of all the bags of candy was 4 ounces. How many bags of candy did she buy? Yeah, so I guess in this one it wants to know individually if we want which kind of bags of candy. So I'll change this over here. Really, it was kind of a poorly written question. What it should say, the total weight of all the bags of candy was 400 ounces. How many bags of each kind of candy did she buy is what the question should say. Then I wouldn't need all this nonsense, but they didn't do a good job of explaining that. So I'm going to say we have different kinds of candy. So bags of caramel. So we'll say X is bags of caramel. And we'll say Y is bags of taffy. And now we can write two equations that go with it. Ariel bought several bags of caramel candy and several bags of taffy. The number of bags of taffy was 5 more than the number of bags of caramel. So if you take the number of bags of caramel and you add 5 to it, and you add 5 to the number of bags of caramel, you'll get the bags of taffy, right? There's more bags of taffy. The number of bags of taffy was 5 more than the number of bags of caramel. Here's how many bags of caramel plus 5 is this many bags of taffy. Next, taffy weighs 8 ounces and caramel weighs 16 ounces. And altogether, it weighed 400 ounces. So I don't know if this is going to ask us to do equal values or whatever, but I'm going to actually use substitution. Hey, look, X plus 5 equals Y. This is like 2 $5 bills and this is like a $10 bill. So I'm going to go take this $10 bill out of this equation and plug in 2 $5 bills. And the reason why I'm going to do that, I want you to see what I'm talking about. The reason why I'm going to do that is because I went from 2 variables, a y and an x, to only x's. And is that important? Well, again, this has one solution. This has infinite solutions, right? If I can pin it down to one variable, I can get an answer. If I can pin it down to one variable, I can get an answer. If it looks like this, I'll never get an answer. So here's what we have. 8x plus 40 plus 16x equals 400. You can see I'm quickly running out of room. Boy, I feel like I've made some mistakes here, but I'm just going to keep going. Actually, might need a little room over here as well. So I think I'll clear off a little bit of room here in case I need that room as well. All right, so I get 24x plus 40 equals 400. So 24x equals 360, which if I divide both by 24, I think x equals 15. So I have 15 bags of caramel, which means I must have 20 bags of taffy. Now let's check that answer. If I plug 20 into this equation, 8 times 20 is 160, plus if I plug 15 into this equation, 16 times 10 is 160, half of that is 80, so 160 plus 80 is 240, and that needs to equal 400, and it does, so this is my answer. So I got there eventually, kind of ugly getting there, but I did get there, so that makes me happy. All right, so let's go ahead and open the next one, 621B, and let's keep going. So 647, when you write equations to solve word problems, you sometimes end up with 2 equations like Renard's or similar to the 2 equations below. Notice that the second equation is solved for y, but the first is not. So what they're saying is, hey, and I guess because you guys are in advanced class, I'm kind of jumping ahead with this, but the idea would be, I'm showing you substitution already. They're saying take this and solve it for y, so y equals y and we can solve it. But what I'm saying is, hey, look, why don't we just take this y out and substitute it with this? So I'm going to go to this equation, x minus 2, and I'm going to take this y out and I'm going to replace it with negative 1/2 x plus 4 equals 4. So again, this y has been replaced by what a y is worth. Now I can solve. If I distribute a negative 2, a negative times a negative is positive. Half of 2 is 1. So I get plus x, plus 1x, right? Minus 8 equals 4. I add 8, I get 2x equals 12. So x equals 6. And now I can substitute that in here. If x equals 6, half of 6 is 3, and negative is negative 3 plus 4 is 1. So y is 1. And then I'll just check this to see if 6 minus 2 equals 4, and it does. So there we go. That's substitution. That's a little bit different than what they wanted us to do here. They wanted us to use equal values, but I didn't want to. So we know this meets in 1 point at 6, 1, right? My x is 6, my y is 1. My ordered pair is xy. All right, and then finally, just to wrap up 648, by the way, you just got introduced to substitution out of order. We'll deal with more substitution in later sections. Solve the system using equal values. So again, we're looking at this. Ugh, man, I really don't want to use the equal values on this, but I will. So x plus, there's something called elimination. This problem is perfect for, but I'll save elimination. Since I showed you substitution early, you know what? I'll solve it, then I'll show you elimination. So let's solve this for x. So I know that x is equal to negative 2y plus 14. Here I know that x, if I add x to both sides and subtract 26, I'll get 3y minus 26 equals x. So then I could say, hey, look, they're both equal to x, so they must both be equal to each other. Add 2y, add 26, 40 equals 5y, so y equals 8. If y equals 8, I go here, I get negative 16 plus 14, so x equals negative 2. And then I'll plug both of those in here. I get 24 minus 26 equals negative 2, so I'm happy with that. By the way, here's elimination. Elimination says if I add these lines together, these go away. I get 5y equals 40. I divide by 5, y equals 8. So you can see this question was set up for elimination, like this one was set up for substitution. So I think the book is basically saying, hey, look, you can go the long way and do equal values method, but you're going to learn some shortcuts coming. Anyway, hopefully that made sense. Again, substitution and elimination are both coming in later sections. If they didn't make sense now, you can just solve everything for y or x and then use equal values.